calculate the length of the longest rod that can be kept in a room of dimensions 5 meter, 4 meter and 3 meter. So it is a problem from rectangular parallelepiped or cuboid. So there is a room, the dimensions are given 5 meter, 4 meter and 3 meter, and we have to find the length of the longest rod that can be kept inside the room. So solution. So let us draw the room first. So this is a room where the dimensions are given 5 meter, 4 meter and 3 meter. So you will take the longest one, 5 meter as the length. So this is the length, and the next one 4 meter is breadth and 3 meter is height. Okay, you can take any one as length, breadth and length, and you can interchange these dimensions. Okay, it does not matter, but for keeping with convention, the longest one is length, then the next one is breadth, and this one is remaining one is height, suppose. So in this room it is cuboid shape. So we have to calculate the length of the longest rod. So what is the longest to find the length of the longest rod, we have to find the longest line that can be drawn inside this room or the cuboid. So how to draw the longest line inside a room, inside a cuboid? We know that the line joining one vertex of a cuboid to the opposite vertex, that is the longest line. Okay, the line can be drawn from this one to this one, this vertex to the opposite vertex, or this vertex to the opposite vertex, or this vertex to the opposite vertex. It will be same. So this line is the longest one, the longest line that can be drawn inside the cuboid or the room. This is also known as space diagonal, okay, or body diagonal, or simply we say it is diagonal. So the vertex from so the diagonal from one vertex to the opposite vertex inside the cuboid, that is space diagonal, or simply we say it is diagonal. So that represents the longest line that is possible inside the cuboid. So if that is the longest line, so it follows that it will be the length of the, if we find the length of the diagonal, then it will represent the length of the longest rod that can be inside the cuboid. So the solution will be like this. Given length, suppose it is L, 5 meter, breadth, suppose B, 4 meter, and height, suppose H, this is 3 meter. So we have length, breadth and height, all 3 dimensions. So the formula for the diagonal from one vertex to the other, or the space diagonal or the diagonal, is suppose diagonal is represented by D. It is length square, breadth square plus height square. This is the formula. Okay. To find the diagonal from one vertex to the opposite, we use this formula: length square, breadth square plus height square. Then square root of length square, square root of diagonal is square root of length square, breadth square plus height square. So if we substitute the values, we get 5 square, 4 square, 3 square, right? This is equal to 25 plus 16 plus 9. How much it is? 25, 25, 25, 50. 50. This is equal to 5 into 5, 5 square root of. So that is the value. Hence, the length of the longest rod is equal to 5 square root and meter. Okay, because the unit is meter. Okay, so we are using 5 square root meter, and don't forget this unit, otherwise the solution will not be accepted. So you have to put the unit also, and that is our answer. Now one more thing is that this is the solution. Okay, so such questions, the marks given for such questions are 2 or 3 or sometimes 4 and maybe sometimes 5. So the solution that you will write, how much you will explain, that will depend on the marks that is given. So if it is 2 marks question, then the solution that you write, that will not involve this diagram and all, only this part, only the solution part. Okay, up to this, nothing else. So you can just input the solution, the formula, and you can get the value like this. So that is one part. Next thing is, if it is more, if marks given is more, then you can draw the diagram, okay, to explain how you arrive at the solution. Fine. So depending on the marks given, you can write only this one, it will be okay, fine. Or you can if the marks given, if the mark given is more, then you can write the diagram also to illustrate. Fine. Now, did you understand how we arrived at this formula? I have taken another class previously where I explained how we get the diagonal, the length of the space diagonal, how we arrive at this formula. Okay, so that should be clear. But if you have not understood how we arrive at this formula, then let me just recap it for you. Shall we? So to understand how we arrive at this formula, this is for explanation only. Okay, see, this is a cuboid. Okay, the room is cuboid. Now to find the diagonal, we have to know the dimensions. How we arrive at the formula is something like this. This is how we arrive at the formula. Suppose this is a diagonal, this is a surface diagonal. Okay, from on the surface, this is a surface diagonal. Now this one is a right angle triangle. If this one is a right angle triangle, then we can, to find this line, sorry, this is a surface diagonal, and this one here, here and here, this is a right angle triangle, right? And to find the length of this diagonal, the surface diagonal, we can use Pythagoras theorem. So we know this length, this is 4 meter. Okay, so we know this length and this length. So we have to just find the hypotenuse. This is the hypotenuse because this is a right angle triangle. So how do we get this value? This value, you square it. This value is given as square root of 4 square plus 5 square, right? This value, this is square root of 4 square plus 5 square meter. Okay, because we are using Pythagoras theorem here. Now if this is known, this value is known, then this is another right angle triangle, and we have measures now, found the measure of this line, and this line, the length of this line is also known because this is 3 meter, the height. Okay, this line is known and this line is known. So from this right angle triangle we can get this value, again applying Pythagoras theorem, right? So what will be the value of this diagonal hypotenuse? It will be this one is square plus this one is square root over, right? Square root of, suppose this is D, this is equal to, this hypotenuse is equal to this 3m square, then this square, and this value is equal to 4 square plus 5 square plus 3 square, this one, right? And this is equal to how much? L square plus B square plus height square, length square, breadth square and height square. Okay, so to find this diagonal we use the Pythagoras theorem twice. First we find out this value from here to here, this line, then we find again we use Pythagoras theorem to find this value because we know this line and this line. Then to find this line we use Pythagoras theorem. We already have the length of this line and this line, and by using Pythagoras theorem we see that the value of this diagonal, the space diagonal, or the body diagonal, that is length² plus breadth² plus height². Okay, this one. So substituting the values, we get it is equal to 5 square root 2. So that is how we arrive at the length of the longest road. Okay, so this is the explanation of how we get the space diagonal. Fine. So depending on the mark given, you can just write the solution like this, or if the mark given is more, then you can also include a diagram like this. And remember the formula, the value of a diagonal is found by squaring the length, breadth and height, adding them and taking the square root like this. And don't forget to use the unit. This is important. Okay, otherwise the solution may not be accepted.